Your friend tells you she has 7 coins in her hand, just pennies, nickels, dimes, and quarters. If you guess how many of each kind of coin she has, she will give them to you. If you guess randomly, what is the probability that you will be correct? We'll first determine the total number of possible outcomes using the stars and bars method of counting, and then we'll determine the probability you randomly guessed correct. To begin, because there are 7 coins of unknown type, we have 7 stars, or we can say we have 7 indistinguishable coins. And because the coins must either be pennies, nickels, dimes, or quarters, there are 4 distinguishable or 4 possible coins, and therefore we have 3 bars. The number of bars is always 1 less than the number of distinguishable items, or in this case, the number of distinguishable coins. And we'll use P for pennies, N for nickels, D for dimes, and Q for quarters. From here, every time we form a string of length 10 with 7 stars and 3 bars, it represents 1 possible outcome for the 7 coins. Let's look at 3 examples. We always begin with pennies, and for the first stars and bars chart, we begin with a star, and therefore one of the coins is a penny. And then we have a bar, which means we switch from pennies to nickels. And then we have 2 stars, which indicates we have 2 nickels. And then we have another bar, and therefore we switch from nickels to dimes. And then we have 2 stars, which indicates we have 2 dimes. And then we have another bar, which indicates we switch from dimes to quarters, and then we have 2 stars, indicating we have 2 quarters. So one possible outcome is 1 penny, 2 nickels, 2 dimes, and 2 quarters. The next stars and bars chart begins with a bar, which indicates we switch from pennies to nickels, and then we have 2 stars, indicating we have 2 nickels, and then we have a bar, and therefore we switch from nickels to dimes. We have 1 star, and therefore we have 1 dime. And then we have another bar, indicating we switch from dimes to quarters, and then we have 4 stars, indicating we have 4 quarters. And for one more example, we begin with a star, and therefore we have 1 penny, and then we have a bar, and therefore we switch from pennies to nickels, and then we have 3 stars, indicating we have 3 nickels. We have another bar, indicating we switch from nickels to dimes, and then we have 3 stars, indicating we have 3 dimes, and then we have one more bar, which indicates we switch from dimes to quarters, but there are no more stars, and therefore we're done. So the total number of outcomes is equal to the number of strings we can form with 7 stars and 3 bars, which is equal to the sum of these stars and bars choose the number of bars, which in this case is 10 choose 3. And this shouldn't be too surprising. If we think of this in terms of bit strings, where the stars are zeros and the bars are ones, the number of bit strings of length 10 with 3 ones is 10 choose 3. So 10 choose 3 is equal to 10 factorial divided by the product of 10 minus 3 factorial and 3 factorial, which is equal to 10 factorial divided by the product of 7 factorial and 3 factorial. Let's go and simplify by hand. We will expand 10 factorial until we reach 7 factorial. 10 factorial is equal to 10 times 9 times 8 times 7 factorial, all divided by 7 factorial, and then 3 factorial is 3 times 2 times 1. Simplifying, 7 factorial divided by itself simplifies to 1. 8 and 2 share a common factor of 2. There's 1, 2, and 2, and 4 2s and 8. 9 and 3 share a common factor of 3. There's 1, 3, and 3, and 3 3s and 9. We're left with 10 times 3 times 4, which is 120. There are a total of 120 possible outcomes. Therefore, the probability you will guess how many of each kind of coin she has correctly from a random guess is 1 chance out of 120, or the probability is 1 120th. So the probability that you'll win the coins is 1 120th. I hope you found this helpful.